Bro, look at my local disk. 2.84 gigabytes free of 111. Huh? And it's all hibernation files, Windows files. I don't even know if you need these. Should just start deleting stuff. Like, oh, okay, I could delete this. I'm not gonna emulate Android apps soon. 6.4 gigabytes. Also, we've been doing pretty good. The views are up 24%. Impressions, like what? Some of them, I mean, mostly all of them are through the YouTube search because of curiosity, curious people. I'm just trying to make room to download Cursor AI. So today we're going to be trying out the new AI code editor that I just figured out was a thing. It's called Cursor, and you get 2,000 completions. You get a 2-week trial if you want, 50 slow premium requests, and I'm pretty sure these reset probably every week. I would think so. Who owns the code generated in Cursor? You. That's kind of iffy with all the AI stuff that's been going around with whenever ChatGPT came out, and it was supposedly stealing code from GitHub. It's like the GitHub Copilot. GitHub Copilot is trained, I think, on the repositories inside GitHub, only if they're public. Something like that. I don't want to start any controversies now. Don't y'all just love the background? I thought about getting a green screen, but I think it's more aesthetic like this. It's kind of real. Oh, it downloaded, okay. Let's use Emacs. So I just clicked on both of these because it says to add to the command line. I guess it enables features for the actual command line inside the software itself, where auto completes some code, which would, I mean, this is all theory that I'm talking about, but it would be cool, you know? That would be a lot of extensions. What if I use the GitHub Copilot and this at the same time on top of ChatGPT 4.0? Come on, let's sign up. Why not? You never know if I'm gonna start using this or not. Cool, now we have some tasks to do, some games. All right, accept an autocomplete. We got tutorials or showcasing. Oh, it created a tutorial file. Okay, we're gonna do FizzBuzz. I'm gonna do it as a Python because I know FizzBuzz. So usually in GitHub Copilot, we would do this and we would do FizzBuzz, but complicated. You can't complicate. Okay. But without using the module operator. All right, okay. Let it think. What? There's a module in there. Okay, so like this is a vlog style tutorial type deal. Well, I'm trying to make it like it because I do not know how to do a vlog tutorial, because I don't want this to be a basic tutorial to be too in depth, because personally I think programming should be fun in a way, and like this is supposed to be relaxing but yet stressful at the same time, if that makes sense in a programming standpoint. So we would just create a file right now, and then I called it YouTube tutorial things, and then we're just gonna select it. So I created this, and then I went to file, open folder. So next we're gonna create a new file called, we could call it main.js, main.py. We're gonna be programming this all in Python, by the way, and there's also a prerequisite for this. It will be to download the CUDA core drivers. I mean, you can also use your CPU, but of course, if you want faster processing times, you would have to use the GPU for that process. And so right now it prompted me to install Python, the library, I mean the extension like VS Code. It's installing. So here's the website for the CUDA toolkit for the GPU. You would just click on Windows, and then the architecture you're on, and then it should prompt you to download. It'll show up a little screen, check mark all the boxes as much as you can, and then you will have CUDA downloaded. So we are going to be coding. Okay, so basically I just said as an initial prompt, this is going to be a machine learning model that uses the GPU and use the Q-learning algorithm to train the model. This is going to be the frozen world, grid world problem. We will use Pygame to visualize the environment and the agent. We will use PyTorch library to create the neural network. So whenever I was installing PyTorch, I ran into a lot of errors with this one DLL. It was something with C++ and Windows. If you all run into that issue as well, just comment down below and I'll try to resolve it for you. Well, as best as I can, and how I did it, because I think I spent the entire day trying to get it working, and then I finally did, but I forgot the steps. So basically, here is our syllabus right now. We have initialized the Pygame, define the constants, set up the display, define colors, define the grid in the grid world. Where should the AI start, which is going to be the top left, I believe. And then finally the game loop. So let's start. So right here is going to import Pygame, and then we're also going to import, do we need NumPy? We'll import it as we go. But for sure, we need Pygame. And then we need to import the system. So I think it's best if we just code it out instead of me talking about it, because then it's going to be like 30-minute video. And I think it's already around like 6 minutes. I'm not sure. But we defined the constants that we're going to need. We're going to need the width. We're going to need the height. We're going to need rows, columns, and the cell size, how big we want it to be on the screen. So this is also written out like this. If we put width, and then we could equal to could have equaled it to 400. Height is 400. So that's going to be the same as that. So this is just basically the smaller version to compact the code a little bit. And right here, we just set up the display. So it's going to be a window Pygame display.set mode. It's going to set the width and height. Also says right here, Pygame display set caption, which is going to be the top title. I don't know why they just can't call it title. Oh, it's right there, title. And yeah, frozen world, grid world. So right here, I basically implemented the game loop just to display what we are doing. We just created a basic frame. It says frozen world, grid world with a black screen. Right here, the game loop says running while it's running, which is gonna be a forever loop until we hit the quit button. So right here, whenever it's doing this running, it's repeating this for loop every single time it runs that sequence, which is forever. And so it's basically getting the events, and then it's going to check the event type, where the type is pygame.quit, which is the X button, and then the running will be false and the game will close. So I went ahead and defined the colors and the grid that we're going to use. S is going to be the starting, G is going to be the end, and the H's are going to be the boundaries where player dies. So under this grid, I implemented the draw grid, which is going to draw as an X and Y value, so for every row and for every columns. So that will give you coordinates, which is like 0 0 0 1 0 2 all the way to the end, and then it go to 1 1 1 2 1 3. So to visualize that more, so S would be considered 0 0, and F would be 0 1 0 2 0 3, and this is just 0 right here, and then 1 and then 2 and then 3, and then it goes on. So this would be 1. So F would be 1 1, H would be 1 2, and then it goes on. So that's what this code is doing. And then with the cell type, we're going to get the grid, which is what we defined as what we just set, the rows and the columns. And then it's going to loop through that section. So if it's an S, if this 0 0 is an S, which it is, it's going to be green. And then it's not S over here at 0 1, so it's an F, and it'll check if there's an F. So F is just white. Else is F is just white. You could put it as K, you could put it as whatever, it's going to be white. But our important ones are over here, which is S, G, and H. So G is blue, H is black. And then this is just to draw the colors. And then right here, I implemented the agent position, which is going to be 0 0, which is the starting position. And then as the agent player, we're going to define it as a circle. For now, we're going to use arrow keys as the move to move the agent. So inside this game loop, it's using game programming inside of it. So anything from the top to the bottom is going to be constantly rendered out. So that's how game programming works. And as a check, as like instead of turning the background black as we saw, it'll turn it white right here. And then that will be our background. And then it's going to draw the grid, draw the agent on top of the grid. If we had it reversed, it'll be under the grid. So you could think of it as z-index in HTML or in CSS code. And I do not know why, but we need this display that flip. If we don't have that flip, it'll just render nothing. This basically stays the same. It just quit. It'll quit the game. And then I just added this else if statement, capturing the keys, the keystrokes, move the agents. And then right here is a basic collision. So let's run this game, and here it is. If I click the arrow keys, we could see it. And then I just fell into a hole. Game over. So while I was coding this is a cool feature. I showed up like a little debug with AI. And so I did it, and it says here's an additional what I need inside the training.py code. Oh, cool. And then whenever you click apply, it highlights it in red, and then the green shows up saying what's been modified. And we're gonna accept the change just like GitHub and Visual Studio Code. And cool. So basically I refactored every single thing here. I try to make as many comments as I can, of course using AI. So right here, all this basically stayed the same, but right here is where it gets different. And also I renamed this to Frozen Lake _ Pygame to make everything object oriented and more easier to see. This is cool. So I just created one comment and it filled out all these. So let's start from here. We're gonna reset the environment, get the agent's position right here, and then we're gonna set the clock because the render time, the AI needs to know how fast, or you could also adjust the time as well. If you go over here, clock.tick, this will adjust the speed as needed. This stays the same. This is gonna implement a 4x4 grid, so the AI knows everything involving AI is number based, and it cannot see anything. It's just zeros and ones passing through. Well, actually it's 0, 1, 2, and 3s. And then right here, it's a torch with no gradient. Gradient's more labor intensive, but more accurate at the same time. We're gonna get the Q values for the current state. We're gonna get the action with the highest Q value to pick the best approach. And then we're gonna take the action and get the next state, reward, and done flag. Which over here it says environment. Everything with environment right here is gonna be in this grid world _ environment class. It's the same implementation of the grid. Everything is just self-based and object-oriented as possible. So we have the initialization process, which is the grid, action space, and state space. Up, down, left, right. And then we could also do a reset, getting the state, and step, which is what we're calling right here. Which step is the action that is needed to calculate if it's moving or not. So if it's a 0, it'll just go up, or down, or left, or right, which is 0, 1, 2, 3. And then it'll update the current position of the agent. And then of course we have to have some reward system inside a reinforced learning AI that you're gonna create. So right here, if it's an H, if it goes inside a hole, it's gonna be a big penalty saying, no, don't ever do that again. You're basically stressing the robot out and punishing it, and it hurts it. But then if it goes to the goal, it's a big reward, and it gets rewarded with 100, with the number 100. And the bigger the reward or the lower the reward, the more it's gonna fluctuate. So if it's a big negative number, just like this, it's never gonna want to touch the H again. So it's basically giving it trauma on the letter H. And then right here, if you go to the letter G, it's giving it McDonald's or some kind of something that the robot likes, some wires or code, I don't know. And then right here is just initializing the DQN agent. It's found in the Torch library. You could also search it up, do some research, the documentation. This is how you initialize what we're doing. We're using the linear. We're using 64 neurons. And then right here, this forward method is just moving the bot forward. And then all this basically stays the same. If it's done, if the reward is greater than 0, it has reached the goal or fell into a hole. And then all this train _ DQN, it's a lot of math. It's a lot of reading about epsilons, about how artificial intelligence actually works, how many episodes you want to train it on. There's also something called epochs, which is iteration. Like you could visualize it as seasons in an episode. So after season 1, during season 1, it'll be 0 through 1000. After season 2, it'll be 0 to 1000, but the story progresses in those seasons. And right here, the memory size, the batch size is all dedicated to your machine. You can lower these if it's more intensive on your machine. The code could be condensed almost half of the code if it was all text based, but we're doing a visualization right now. So that's why you see you could condense it to 3 classes instead of 4. You could just train the data and just be done with it and get the most data out of it instead of visualizing it and using only the built-in tensor board logging system, which it will just show up a big old UI graph. I don't think it is implemented in here. I did try the training data, as you can see down here. It did work. And now for every episode, which is going to be 1,000 episodes, we're going to do basically the game that we just implemented over here, but more in depth. And so the AI could actually read it, that's why we have NPs up in here. We have NPs arrays, which is the NumPy, which it's all numbers. And then you have weird stuff like this, which is totally AI generated, because I would not to ever think of that unless I were to go to the documentation, because then it would be there. So now, I got it popped up right here. So it says debug with AI, add to chat, add to composer. I don't know what composer is, but let's check it out. Oh, cool. So we're gonna train the AI. Let's see. I'm pretty sure it's gonna go super fast. Yeah, because of my upgraded graphics card, 24 gigabytes of VRAM. So we're just gonna give it a little bit here. So after the training has completed, we're gonna launch the Frozen Lake game. I'm not touching anything. Let's see what it does. So actually I made an error right here. It's supposed to be indented, so it's actually inside the for loop instead of outside the for loop, and saving one time instead of every single episode that it encounters, which is the most important part, because that's how the AI reads its own data, which is this. It somehow, some way it reads this, and it's gonna be, well, this was for one episode, which is 157 lines. I don't even know how many characters, or 23,000. Yeah, 23,500 characters. Yeah, and multiply that by 1,000. So now if we were to run it, it will go right there, down there, right, and boom, the AI solved it. And then it just resets, and it'll just repeat it. So you can take this, you could modify it the way you want it. So right here, I just added an H down here, and it just keeps on wanting to do that same path. And that's why you need to relearn the algorithm, or have the algorithm keep on going and make it so it'll adjust to environment changes, such as if we were to click on a block, it will change it to black and to a hole, and then it will just go left and right unlimited times until you unlock that hole, and then it will go down to the end goal. That's a separate project. I'm pretty sure it's a lot of code to do that. But yeah, you can make it the way you want it. You could train it how you want it. I just moved this to an H. This could be F again, and then we will rerun it, and it will work just fine. But if y'all have any questions, I majored in systems programming, not artificial intelligence, but I've only taken one course. So I'm basically a professional, so you could just comment your questions, and then I'll try to answer them the best I can. If you like the video, want more, please like, comment, and subscribe.